Hello guys, today I'm gonna talk about background information and hypotheses in internal assessment in group 4 science in IBDP. Previously I introduced my general suggested map for the structure of IA, specifically in science. It starts from title, which is your research question, and then re-explaining of research question that both were explained in previous video. Now I will concentrate on background information and hypothesis. Let's go. In background information, you are supposed to provide enough information relevant to the research question to support your hypothesis. You know your IA is started by a research question, and then you will have an answer to your research question at the beginning. It is called hypothesis. Hypothesis is an educated guess as an answer to your research question. Here, the reason for the background information is exactly to support the hypothesis, so it must be highly relevant to your research question. As an example, how altitude of airplane can affect fuel consumption in turbofan jet engines. Here, altitude is your cause or independent variable, and fuel consumption your dependent variable, or let's say the effect. And it's focused on turbofan jet engines. So you should use credible resources to concisely present information about, number one, what is turbofan jet engine, and number two, why altitude can affect fuel consumption. That's all. In your background information, please avoid verbosity, avoid writing irrelevant sentences. In this case, seriously avoid detailed statistics, tables, and graphs. They are very good to have, but not here. In future, in your raw data, in your analysis, in your results, you will explain detailed statistics, tables, everything you want. It's not the proper place. Number two, talking about different types of jet engines. No, you are focused on turbofan jet engine. Why talking about the other types? Number three, avoid talking about why is it worth investigating fuel consumption. It's irrelevant. And number four, talking about other factors affecting fuel consumption. You are checking and considering the effect of altitude on fuel consumption. Forget about the other factors. They are irrelevant and they are taken as verbosity. Hypothesis. Hypothesis is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. In short, it's an educated guess as an answer to your research question. Usually the format of your hypothesis is in the form of if or when this, then this. So it's explaining how the cause can bring this effect. And there is a because here which has already been supported by your background information. Hypothesis would include educated guess, as I told you about your research question. And this educated guess must be supported by background information. Let's have an example. How temperature can affect a spring constant in a steel spring. Okay? Here the temperature is the cause and the effect is the spring constant or elastic constant of this specific type of spring. So it could be your hypothesis. If or when temperature increases, then a spring constant will decrease because molecular bonds of the solid go weak to hold the structure tightly as before. Example 2. How does the pH of a sodium hydroxide solution affect the rate of its reaction with ethyl acetate in a saponification reaction? The hypothesis could look like if or when pH of the solution increases, then reaction rate will drop because the solution is base resistive and stems more chemical reactions. Here you see not only the student explains how the cause can make this effect, also there is a because. And this because has already been supported by the background information. Can I support my prediction in pictorial format like graphs of my own? Yes, of course you can. But any prediction you make for the graph, trend line, fluctuation, linear, nonlinear, whatever, must be supported by a scientific reasoning. If you believe that your dependent variable will have a fluctuation like this, a nonlinear behavior like this versus the independent variable, you should explain it in an educated way, in scientific format. And Finally, extreme and noun points will help you in this prediction. What do I mean by that? Let's say we have a wind generator, and I'm going to consider the voltage generated by this wind generator, wind turbine, versus the wind speed. Okay, I increase the wind speed and I check the voltage, but I know that the rated voltage on this generator is 120 volts. So the voltage will not exceed 120 volts in maximum wind speed, as it cannot pass the full capacity of generator. This is a maximum in your prediction, and you know that you won't pass 120 volts. So in your prediction, you predict that, okay, it's nonlinear like that, but you will have also a maximum. Yes, you can produce a rough graph like this as your estimated graph or the future graph you may see. What if my prediction won't come true? No problem. Shall I change my hypothesis in this case? Of course no. So what should I do if there is a difference between my prediction and results? Good question. You will consider possible reasons of this difference in evaluation at the end of your IA. So keep your prediction the same as you have already made, and then consider them in evaluation. You are learning through investigation. This is the goal of IA. Don't worry. We are at the end of this video. Thank you for watching, and thank you for being with me. The next video will be about variables and methodology. See you soon.